Good evening, everyone. This video is going to go along with the task sheet 663 that's on camshaft and crankshaft position sensors. So I just kind of wanted to show you guys the diagram and show you guys the scope real quick before we get to hooking it up. But here is my drawing of the wiring diagram for these circuits. It's pretty straightforward. We have CMP. That's going to be our camshaft position sensor. CKP is going to be our crankshaft position sensor. And that's pretty universal, CMP and CKP. So just something to remember. But all these are 3-wire sensors. You can see there's no connectors anywhere in these circuits. And that's not too terribly uncommon. They don't want to put connectors or splices in line with some of this stuff. It's just more room for error. So on certain critical sensors like this, they'll just run straight wiring and not have any connectors. So we won't have any other opportunity for failure. So when we hook these up, typically with 3-wire sensors or with most of these sensors, what we're looking for is always going to be our signal wire. So pin A on both of these is our signal wire. Pin B on both of these is low reference, which is like a ground for the sensor, but it's a ground through the PCM. So anytime you see low reference, that's not going to be a chassis ground, that's going back to the PCM. And then we have our feed, our power feed from the ignition. So really all we need to do to hook our scope up to any of these 3-wire sensors is back probe somehow or pierce the wires. And we just need to tap into that signal wire. On our lab scope, we'll hook one of our leads to that signal and then the other one goes to ground, and that's it. That's all we have to do. I ran up to the school today and grabbed another scope. This is another snap-on tool. This is a Vantage Ultra. It's very similar to the scope that's built in to the other scan tool that we have been using. Just for some reason that the scope in that scanner just isn't working. So this is just a standalone scope, but it still has a lot of the same features. It has guided component tests, which is what we're going to use. You can go in and build out your vehicle just like you were using a scan tool. And it'll give you some options for different tests that you can run. And it will actually tell you like what wires to hook up. It'll give you little pictures of the connectors of the components if you need to. And the signature tests is what we're going to be doing. It'll give you a little a picture of what a good waveform looks like, so you kind of have something to compare your data to. So when you look at the waveforms on these, it's good to visually see something, but I mean, if you don't know what it's supposed to look like, it's not really going to do you a whole lot of good. So these tools are pretty powerful, and they actually have a lot of information already built into them. So there's a couple ports on the top. There's a ground. And then this is what you'd call a 2-channel scope. It's got 2 other ports for leads. So a 2-channel means you can hook up and be looking at 2 different waveforms at the same time. And they do make some that are 4-channel, things like that. But obviously you're going to pay a little bit more money for that kind of thing. But even still, this is still a pretty good tool to have around, especially if you do a lot of drivability and you get some kind of weird problems. These can definitely help out quite a bit. So we're going to go ahead and go over to the truck and get this thing hooked up and show you guys some what some waveforms look like. All right, so we've got our scope hooked up here. We're out under the hood of the truck. This is what our home screen looks like. We've got guided component tests. We've got scope, multimeter, previous vehicles, and tools. So the guided component test is what we're going to use. It actually kind of walks you through some different things, gives you a little extra information. The scope or multimeter, that's if you just want to kind of do this yourself, just pull up the scope and hook things up without any of the guidance of the other section. There's also a graphing multimeter in here, which is it's like your multimeter that you're used to, but it's going to show it in a visual way versus just numbers. And speaking of multimeters, that's one of the things about these, why these scopes are different, is because they sample so much faster that you could hook up to a sensor with a meter, and yeah, you may be able to read some things, but the scope samples thousands of times a second. So if you have a sensor like a cam position sensor that's constantly cycling back and forth, it's just too fast for the meter to pick up. So that's why we need the scope, because it's fast enough that it can catch all that information. So just to show you guys how I have this hooked up, I went to the PCM since it was easier for me to get to. So it normally lives kind of down in this bracket, but I pulled it out to get some access. You can see we're in pin like 73, I believe, and I have pierced the wire. I'm not a big fan of that. If you can back probe, you probably should. But if you do pierce the wire, make sure that you're plugging that hole back up with something. Either it's tape or some kind of adhesive or something, so you don't get any water intrusion into those wires after you are done testing. So we're hooked up to the cam position sensor signal wire right now, and we've got our black lead to ground. You can see how we're hooked up here. This is all one piece of cable. So we've got our black lead stacked up into ground, and then our yellow into the yellow. So here we go. We're going to go through guided component tests. And this is a lot like using a scan tool. We're going to build out our vehicle. So we've got a GMC. Scroll down. 99. This is a C2500 with a 5.3. I'm going to go ahead and load that vehicle. And you can see we have a few different options here on what we want to look at, some different systems that this can do. ABS, you may want to look at a wheel speed sensor or something like that, see if you got a missing tooth or something like that on a reluctor. But we're going to go into fuel injection here, and we're going to go to CMP. Remember, that's our camshaft position sensor. So we're going to go to CMP. And here's a few different tests we can do. I'm going to go to the signature test. That's going to give us our waveform. So you'll come up to a screen like this. This is what our screen's going to look like. And it's not going to do anything until we start the vehicle up. You see down here at the bottom we have this little area. And you can expand this a little bit, but it's telling you that to hook this up, we need the test leads from the scope, the yellow one to be on our signal, and the black wire to be on a ground. If we scroll down, that's what our connector at the cam position sensor looks like. And it gives you a little pin out there. If you want to go to the PCM, there's a connector end view of that as well. And it gives you, we're looking, pin 73 is our signal, and it's a brown and white wire. So it tells you right where to hook this thing up. There's connector 2 at the PCM if you need it. And as we go down, it kind of gives you, it's kind of hard to see without blowing it up, but here we go. That's what our waveform is supposed to look like. So when this thing's running, that's what we want to see, a waveform like that. So I'm going to go back into signature test and start this thing up, and we'll see how it looks. So we got the truck running, it's just sitting here at idle, and this is what our waveform looks like. This is what we call a square wave. This is a digital sensor. It's on and off. An analog sensor would have like a wave to it. We call it a sine wave, but this is what we call a square wave. You can see our scale on the left is going to be voltage, so we're going from 12 volts to 0 volts. So 12 volts is on and 0 volts is off, and it just switches back and forth and back and forth. It doesn't look like it's doing a whole lot now, but what we can do, let's see if I can do this real quick. We give this thing a little bit of gas. You can see how much that pattern kind of tightens up when we add a little RPM to it. That's just with the speed increase, we're getting that on-off signal that much faster, and we tighten up on our waveform. So it's pretty simple to use. To be honest with you, I didn't use the scope a whole lot in the field. I was a little bit more focused in other areas, but I know a lot of guys that do a lot of drivability, handle a lot of weird problems and stuff. Man, they love these scopes. They'll hook them up to anything. You can use them on sensors like this. You can use them on the ignition system, on coils. You can use them on fuel injectors. All kinds of good tests you can run with these scopes. So, but really, again, it's kind of a recurring theme. We're kind of looking for oddball stuff. So we want this signal to look nice and even. This one at least. So as long as we don't see anything out of the ordinary in our waveform, we know that the sensor is probably going to be pretty good. Like I said, this is hooked to the signal wire, so this is exactly what the PCM is seeing. So we get a little bit of a peek at this data that we wouldn't normally if we were using a scan tool or a meter. But I'm gonna shut the truck down and hook this up to the crankshaft position sensor, and we'll take a look at that one. So I've got our crankshaft position sensor signature test pulled up here, and this is the info that we have in the scan tool. Again, with our connector view of our PCM, our yellow lead again goes to the signal. Oh, I hit the wrong button there. There we go. Another little connector view, and then here is what our signal is supposed to look like. You notice it's a little different. So this one isn't going to be as even or as symmetrical as the cam position sensor is. A lot of times these sensors will have kind of a different spot in the waveform. It's a reference mark. So it knows where, the cycle is beginning again. So if it was always even, you may not necessarily know where things are at. So they'll include a spot in there where the signal's a little different, just so it knows where up is, but they'll call that a reference. So I'm going to start this thing up here in just a second. Again, how we're hooked up, we're just pierced into the signal wire, and we're going to ground. So let me get this started up and we'll take a look at our wave. So here's our wave out of our crankshafts. You see this one looks a little different. Maybe it's moving a little bit faster. Our crankshaft is going to run faster than our camshaft, so you expect to see a little bit more movement out of this one. It's the same kind of thing. We're going to take a look at this waveform, make sure we don't have any kind of weird dropouts or bad spots in it. This one may be a little bit harder to catch since the waveform isn't quite as uniform, but we do at least have a reference to look at. So we can do the same thing, give this thing a little bit of speed. We're going to tighten that waveform up. So you can see when you put a little bit more RPMs into this thing and it tightens that signal up, you can kind of get a better picture of it. You can change the scales on these a little bit, so you can maybe see a little bit more of the waveform. Another thing you can do is this little red dot up here. You can hit that, and it's going to kind of pause it, and you can move it back and forth. So you can, if you think you have a bad spot, you can go back and look without having to catch it live. Because some of these go so fast that that's kind of hard to do. So it's nice to be able to slow this thing down or put a stop to it so we can look at our waveform a little bit more closely. It looks like we can probably save that waveform, and I'd imagine we can get it out of this tool if we need to. But that's about it. That's how we're going to hook up this scope to most of our sensors. Again, we're just looking for a signal wire and a ground, and we'll be able to see exactly what the module is seeing. So you'd never be able to get this much detail out of a meter. It would just be numbers kind of flashing around the screen quite a bit. So if you're going to be doing this kind of testing, a scope is something that you're going to have. So as far as the task sheets go, if it's going to ask for a customer complaint, we'll say that the vehicle has an extended crank, and that we found we didn't have a camshaft position signal. So what I really just wanted you guys to know is how to hook this up and kind of what we're looking for. But fill that sheet out the best you can, and we'll move on to the next.